As we mentioned before, when we're thinking about our APIs, we really want to consider their usability. That is, how easy is it for a developer to look at our API and learn how to use it to accomplish their specific tasks? A core part of this process is to think about the affordances we give a developer for an API. What kinds of names do we give our APIs? How can we make it clear what actions they perform and what protocols are required in order to make the actions string together to perform specific tasks? So when we're thinking about the usability of our APIs, we really want to take some aspects of good development practice and combine it with good usability practice, where we think about our users, we think about their tasks, and we try to design our APIs in a way that make it easy for users to use our APIs correctly and hard for them to use them incorrectly. Let's take a look at 4 specific aspects of API usability, 4 principles that we can keep in mind when we're designing our APIs. So the first is visibility. Right, so what we want to think about when we're thinking in terms of API visibility is we want to make it easy for a developer to look at our API and understand what it does. And when we're thinking in this way, what we want to do is really prioritize what parts of the API are most important. If we have 1,000 API methods, but every task uses 2 of them, we want to make sure that those API methods or classes are extremely prominent so developers can easily find them. And we also want to make it hard for a developer to misuse an API. So let's take a look at a concrete example of how we can improve the visibility of an API in a way that makes it harder to misuse an API. So let's consider a sorting method within an online store, or just a store of any kind. Right? So we have a collection of items that we want to sort. Now, we have a lot of options here for how we can manage this sorting artifact, but what we're just going to do is we're going to pass in a string here according to the parameter that we want to sort on. Right, so this just says we want to sort the items based on their clearance attribute, right? So those items that are on clearance should be sorted first. So let's go and transform this and make it a little bit harder to misuse this API. Because if you think about it, if you spell clearance wrong or you don't know what the other words are, it can be easy to confuse the sort routine in a way where it's not going to know what to sort on. All right, so let's try to fix this up. So what we're going to do instead of taking a string here is we'll use an enumeration, right, which makes it much clearer for the developer to see what are the options that are available for sorting. And in this way, the developer can quickly go and look at the filter enumeration and see what all of the options are and just use them directly. Also, the type checker within TypeScript, in this case, will go and check this enumeration to make sure we're using a valid value. Right, so this is a way where we can make a small change to the visibility of specifically this parameter that makes it easier for a developer to understand how to use the sort routine. Next, we want to think about the model that a developer using our API has to keep in mind. And when we're thinking about the model, we want to provide them with the abstractions that make it easy for them to accomplish their tasks. Right, so what we want to do is we want to consider, for instance, having names that map to the tasks that the developer is trying to accomplish. Right, so let's think about an online store. We could have a method that looks like this for getting an item. Right, so here we're saying, hey, store.getProductID. That's some kind of a string. Right, and instead what we want to say is, hey, this method get isn't extremely descriptive. It doesn't help us to understand what exactly is going on here. So we can make a really simple change to adapt it to fit more the mental model that a developer using our API would have. Right, so this refactoring wouldn't be very complicated. All we need to do is just provide a more descriptive name. Right, and this was an extremely simple change, right? We just changed get to get product, but it makes it easier for the developer to understand what is actually going to happen within this method. Another thing that we want to do is we might want to think about the abstractions that we're providing to the developer. Right? We want the abstractions that we give them to map the level that they're thinking about these kinds of tasks themselves. So again, within the store context, let's think of another way to get an item out of a store. All right, so this is quite complicated, right? So we have store.getDepartment with a department ID, .getShelf with a shelf ID, .get product with a product ID. Right, but if we think about what the developer wants to do, they don't care about the department, and they also don't care about the shelf. What they want to do is they want to just get the product, right? And this drives us towards an API that looks like this one. But this is where we want to see just store.get product with product ID, where we abstract away the notion of a department and a shelf from the developer, right? So this is the kind of case where we want to think about the level of abstraction that we're actually giving to a developer as well. Next, we want to think about ways to use our type system to provide an effective mapping between the ideas that a developer has in mind and the affordances provided by our API. Right, so one concrete example of this would be, again, with get product. Right? So when we think about our definition for get product, what could it look like? It could look like this. And in this case, the API just says, hey, we have get product. It takes a PID, a PID, which we probably define as being product ID, that's a string, and it returns an any. It gives us some kind of object back, or some kind of variable back, but we don't know what it is. Right? But alternatively, we could provide much more detail here, right, with a very simple change. So here what we're saying is this get product API is going to return a product instance, right? And this can be really helpful because, again, as a developer, you know exactly what you're getting back. You can go and look at the type declaration for product and know what fields and properties are available on that object. Right? So this is a really simple change that makes it much clearer for a user of this API to understand what kind of object they're going to get back, and it better suits the internal mental mapping that they'll have for this API. One final property of API usability that's often overlooked is that of feedback. And in terms of feedback, what I mean is we want our APIs at runtime to give the developer, the person who's using that API, constant and early feedback when something erroneous is encountered. But we don't want an API to chug along oblivious to errors or trying to hide errors from the user. We want them to let the user know when they've used an API incorrectly. So let's take a look at a concrete example. Let's go back to that sort example from earlier. Right, so here we say items.sort clearums, right? So that's a mistake, and that's not going to work. Right, so if we go in, the API interprets this method and does its best to sort or returns the items in an unsorted manner or an incorrectly sorted manner, it's not going to be doing the developer any favors. Right, so what this API should do is as soon as it gets its parameters, it should validate, especially parameters, to make sure that they're meaningful in this context. Right, so sort, as its first action within the API, should check that the parameter makes sense, and when it doesn't, it should throw a meaningful and descriptive error back to the user that says, hey, clearance is not a known key, not a known sort key, right? And it can give that feedback right away. Because when we're thinking about our APIs, we want to make it easy for developers to know when they're doing the right thing, and also make it easy for them to debug when the wrong thing is happening. We can also measure these principles using various metrics when we want to reason about the overall usability of our APIs. So in terms of visibility, one thing that we can measure is how long does it take to learn how to use an API? Again, when there are thousands of API methods, can the developer quickly hone in on the ones they care about the most? In terms of model and mapping, we can think about how many API actions it takes to perform a task, because a developer doesn't actually care about the individual actions, they only care about tasks. So the fewer actions they have to take, the better it is for them, right? So we can think about them in terms of actions. Also for model and mapping, we can think about error rates. How well does the API prevent us from doing something that doesn't actually make sense? How can we make ensure that the developer does the right thing? And finally, in terms of feedback, we can think about error rates as well, right? We can think of actually user satisfaction more than error rates. So we can think about how satisfied is the user of this API, But if the API goes and chugs along and does its best effort but returns the wrong result because it encountered some erroneous condition that it didn't tell the developer about, they're probably not going to be very happy. So we can poll the user satisfaction by talking to developers and seeing what they think about our APIs. Can they trust that they're doing what they expect? And these are all things that we can concretely measure about these 4 principles to help us to understand the overall usability of our APIs.